Hi, welcome to the sixth video in the brackets and factorising topic at National 5. Today we're going to look at a mixture of factorising, specifically terms that require factor to be factorised more than once. Okay, so we're going to look at four things here within success criteria, and this is essentially what we're going to look for here. The first thing you need to do when you're looking to factorise an expression in isolation is check if it's got any common factors. If you've got any common factors, get those common factors out. Okay, for two reasons. One, if you remove any common factors, what you'll be left with will be easier to factorise. And secondly, and actually more importantly, it is the most kind of foolproof way of making sure you factorise an expression fully. You take out everything that can be taken out. So the first thing you need to do is make sure if you have any common factors, you take them out. Then have a look and see if what you are left with inside the bracket can be factorised further. Okay, so have a look to see if there's any differences between squares or trinomials there, and then factorise them if necessary. Okay, so just three examples to look at today. Okay, firstly, factorising that expression 2x squared subtract 18. Okay, now I would imagine a lot of you are looking at it thinking that looks like a difference of two squares. Okay, but 18 isn't a square number. Okay, not for an integer. Okay, so 2x squared minus 18 looks like a difference of squares, but it's not. And the reason for that is you have to look at that and notice that there's a common factor of 2. Okay, 2x squared has a 2 in it and 18 is an even number. Okay, so the first thing we should be doing here is taking out that factor of 2. 2 bracket x squared minus 9. Okay, now the risk is that you'll do that and think, oh, job done, I've factorised. Okay, there's the brackets, I've done. Okay, but what you need to notice is that once you look in there, that x squared plus 9, that is actually a difference of two squares on its own. Right, that is x squared, and that 9 is 3 squared. Okay, so that x squared minus 9 factorises further. Okay, it's going to become x plus 3x minus 3, which means the whole expression, that 2 is not going to magically disappear. It's 2, and then in brackets x plus 3, x minus 3. So you can see we had to take two steps here to factorise that properly. Firstly, with the common factor. Secondly, with the difference of two squares. Okay, let's move on to another example. Okay, B here. 3t squared plus 9t plus 6. Okay, now again, you jump in, think that's a trinomial, need to factorise it. But if you notice there, 3t squared, 9t, and 6 all have a factor of 3. Okay, and I'm hoping this one in particular shows you actually makes it nice and easy to factorise if you can spot that. Okay, so t squared plus 3t plus 2. The 3 is still going to be at the start, that doesn't disappear. That trinomial, well, the t squared is going to be t and t. The 2, you're talking about a positive, so the signs are the same. The 3 is positive, so they're both positive. And the 2 and the 1 will give you the 3. So there's your factorisation. Okay, so be very careful that if there is a common factor, you get it there. 1, it makes factorise easier. 2, to ensure you fully factorise it, that's the most foolproof way. And last, actually, you're going to get a mark as well. Okay, so just that common factor will get you a mark. Okay, so take the easy mark when it's there for you. Okay, last example, 10f squared minus 35f minus 75. Okay, so firstly, there's a factor of 5. That'll leave me 2f squared minus 7f minus 15. Okay, that 2f squared, the factors are 2f and f. Okay, the 15 will be 1 and 15 and 3 and 5. Okay, it's a negative, so we know that one of these has to be negative. Okay, so let's go minus 1 and 15, and then swap round 15 and minus 1. Okay, and then 1 and negative 15, and negative 15 and 1. Okay, and then the same again for the 3 and the 5. Minus 3 and 5, 5 and minus 3, and then 3 and minus 5, minus 5 and 3. Okay, so 8 ones to try. Okay, 2f times 15 is 30, f minus 1 is 29f. Okay, now after you've laid out your table, you'll be able to knock some out quite quickly. Okay, so that's obviously no right. 2f minus 1 is minus 2f, f times 15 is 15f, that's 13f, no good. That's minus 30 plus 1, that'll be minus 29f, no good. In the same way, that will be minus 13f, which is no good. So none of the first four are any good. 2f times 5 is 10f, minus 3 times f is minus 3f, so that's 10f minus 3f is positive 7f, not quite. Okay, now I know those give me the right kind of value. Let's look at the signs change round. 2 on, 2f times negative 5 is negative 10f, f times 3 is negative 7f. So that one there, 2f goes with 3, f goes with minus 5. So it's 5, 2f plus 3, and f subtract 5, that's the bracket. Okay, that's your factorised fully. Okay, so here, 4 success criteria. Examine for any common factors and remove if you have them. Okay, vital for a number of reasons like I've outlined. Okay, then have a look at what you're left inside the bracket, see if it's got a difference to the square root and trinomials, and factorise again if necessary. Okay, thank you very much.